Hey, it's me, Destin. Welcome back to Smarter Every Day. This is my drill press. Out of all things that humans could send up to Mars on a nuclear-powered robot, a drill was one of the most important things we sent. And the reason we did this, well, think about this. This is the board, and you've seen tree rings, right? If we were to drill into this board and then analyze the shavings that come out of that hole, because of the tree rings, we could go back in time and understand what was going on in this board when the tree was younger, right? That's exactly why they sent a drill to Mars. We want to understand if there were organic molecules inside the rocks of Mars when they formed. But in order to do that, you have to drill below the surface and then analyze the powder. But every article I've ever read about the drill and about how they analyze the powder doesn't really satisfy me. So today on Smarter Every Day, I'm at JPL. This is Mark Rober. Crazy! He's gonna give me a tour of what?
Okay.
You missed your cue. Sorry. We gotta start over. You missed this cue.
No, I didn't realize you asked.
This is my buddy Mark. You remember all that fancy rocket business where we descended the Curiosity rover down to the Martian surface with these fancy rocket cranes? Yeah, he helped work on that. But more importantly, he owes me a ton of favors. So I asked him if he could introduce me to the people behind the drill on the rover. I want to understand exactly how this thing works.
So we are going to the Mars yard, which basically is a simulation of the Martian surface.
Yeah, look both ways before you cross the street and go to Mars.
Behold Mars!
So this is the Curiosity garage?
Yeah. So they'll bring it out here in the yard. You can see here's the tracks. But then when they're just working on something inside, they bring it back into the shed.
Wow. Oh man, so is this the only one? Is this one of a kind?
This is one of a kind. The only one on planet Earth.
I guess it's two of a kind. I'm Destin, what's your name?
Megan.
Can I shake your hand from a long way away? Nice to meet you, Megan. You're running the test?
I'm running it right now, yeah.
That's pretty awesome. He hasn't let you talk at all, but I really want to talk to you, but there's a rover in between us. This duplicate of the Curiosity rover exists so scientists and engineers can test software and tricky maneuvers without having to risk damage to actual flight hardware. Okay, we decided to quit messing around, and Megan's actually going to tell us what the tools are. You know all the tools, right?
I know a lot about the drill and the Chimera since I tested them.
Yeah?
So this is kind of the butt end of the drill right here.
Can I walk over there?
You can come over here, yeah.
I will. So you're clipped in, right?
I am clipped in for ESD.
To the grounding point, okay.
So this, what you see right here, we call Chimera. I have no idea what that acronym is.
It's
but,
basically the tool belt, right?
this is the sample processing.
Okay, I really need to apologize right now because I started geeking out so hard because I was in the room with the rover that I forgot I was making a YouTube video. And I started asking questions, and they were awesome questions. And then they let me run a command on the mast, and I moved it around. It was incredible. Anyway, I went back and I tried to summarize everything I learned when I was offline in this one take. I'm so sorry. So this is the main mast, which is the RSM,
Yep.
which stands for what?
Remote sensing mast.
Okay, and there's two probes on the side here, and these are both for weather. One of them on Mars actively doesn't work at this moment in time.
Correct.
Because it didn't work at landing, right?
Yep.
Okay, so this is the arm here that I'm using to gather samples on Mars, and it uses Megan's drill bit, right?
The official name.
The official name. So that's the drill bit, and it should have enough life to meet our primary objectives on Mars. And after that goes bad for whatever reason, if we want some icing on the cake, then you've got two extra drill bits located down here that you can autonomously swap out.
Correct.
And that'd be the first time that's ever been done on a different planet.
Yes.
And it's going to happen because you worked on it, right?
I want it to happen. It would be really awesome to see.
Excellent. Okay, so over here, looking at the samples. So before we decide what samples we're going to analyze by putting them in this little hole right here, we can put the samples on the plate. We can measure their size both by the fiducials there on the checkerboard or by dropping it through that funnel, right?
Right.
And then once we do that, we can then, if it meets the criteria, we can put it in this hole and analyze it. And after you analyze it, you dump it overboard.
Yep.
Did I get it all right?
Yep.
You're a good teacher. Clearly Megan's a genius. However, there were still some questions that I had. I wanted to understand the exact interaction between drill bit and rock, which is why I came to see Ryan. And what's your title?
Drill systems engineer.
So what's this right here? What do you have?
This is a drill bit assembly.
Okay.
This is not only our drill bit, which if you take a close look, this is a masonry bit. It's not like the cutting bits that you have on your handheld carpentry drill. It's more of a chisel, and it's designed for impact drilling.
Okay. So how does it work?
So first we set our drill preload, our drill stabilizers against the rock to make sure that we have a nice stable configuration. Then we feed forward until we contact the rock.
Okay.
We start our drilling operation with a process we call start hole. So if you can imagine if we're on a rock and not perfectly aligned and there's all these surface features, little divots on the rock, the bit's going to want to walk around. Imagine like if you're trying to cut metal, you usually put a little
pilot hole.
Pilot hole
So you don't
break
break the bit. That's why
right.
Is that the same reason you do it here?
Yeah. So we have a process we call start hole that starts the first 5 millimeters of our hole, and basically what we're doing is chiseling little divots to carve out an asterisk shape. Then we drill that out and we repeat that process as many times as it takes to get down to 5 millimeters. Then we have a good starting point for the rest of our drilling. It's not the rotation that's really cutting the rock so much, it's really the hammering action. Like a jackhammer, and then the rotation that we do is mainly for drawing the powder up through the sheath. We continuously drill until we bottom out the drill, and literally we're bumping up the front face of the drill bit assembly against the rock. Before we drill, we do a triage. We drill a little bit so we can see what the powder is going to look like, because we are worried about if it turns out that this material is hydrated and is somewhat sticky, then it could clog up our drill bit assembly.
Is it on Mars?
It can be, yeah, and that's one of the interesting science findings recently, is that there's a water cycle, an active water cycle near the surface of Mars, even at Gale Crater.
Do you have any of the drill bits that are outside of the drill head?
Not with me here, but I can show you one at my desk if you're interested in seeing what that looks like. I have a 3D printed model of this where the bit itself is metal, but the rest of the housing is clear plastic, so you can see through.
No way. Can we go do that?
Yeah.
So once you drill, you auger the material up into this, right? This housing?
That's right. Yeah, into the first of our 2 chambers within the drill bit assembly. So we have 2 chambers in the drill bit assembly specifically so that it gives us some freedom to be able to move the robotic arm around without worrying about spilling material back out through the exit tube before we're ready to transfer it. So once we draw it into the first chamber, it's in that first chamber until we transfer it through this little slot that you can see here.
Yeah.
So we transfer it through that slot. We use percussion to shake things up, and we use gravity to control which direction the stuff is going.
So that's the mass flow you were talking about. Can I pretend to be the robotic arm for a second?
Please.
Yeah, okay, so
You'd never ask.
yeah. so basically you've got that slot, and so you want to keep that slot down. So you want to go drill, and then you pick it up, and as long as that slot's up top, then you keep all your sample, right?
That's right.
Okay, and so then at that point, whenever you get it to where it needs to go, you can then rotate it over and then dump it through that little slot right there into the next chamber. No, wait,
right.
Back this way, right?
That's right.
Okay, so you kind of
slot to the second chamber.
almost into your hand like this, right?
Yep.
No, then you rotate again and it goes out that port.
That's right.
Okay, so we've drilled our rock and now we've got the powder on the inside of the rock. In a very specific circumstance, if you find a special rock and you think you might actually have organic molecules in the inside of that rock, you've got to baseline your instruments. In order to do this, JPL got pretty clever. They put these cans on the front of the rover to be used only in certain circumstances. I'm going to let Megan explain what they're for. So in these cans, there's what's called OCM, which is organic check material.
Yep, that's right.
Okay, and so the idea is you have a known sample that you can test on Mars so that you can make sure that your sensors are operating correctly, right? And so that's basically the same thing like the color palette back there, so that you can check that your cameras are working correctly. This is the same thing for your sensors to see if you have life on Mars.
Right, for the instruments.
So that's
whatever science tool they want. Yeah.
So you said it's organic, so that's pieces that were alive?
If you're looking for organics on Mars and you think you found organics, you want to send something that has no organics through and analyze it and make sure you don't see any, and then test the thing that has organics again.
So what you're saying is an organic check material is basically like eating a cracker that the fancy wine tasting guys do
To clean out this.
To clean the palate. Get on my level here. Yes. So that's what that is. This is basically a bunch of crackers that you eat between your samples to make sure you know what's going on.
Right.
Excellent. The next time you see a perfectly drilled hole in the surface of Mars, don't think about, a drill press or a percussion drill. Think about a precisely executed group of maneuvers specifically designed to obtain dust. It works like this. You put the drill bit in, you take the drill bit out. You put the drill bit in, and you auger the dust all out. You do the mass transfer by turning Chimera about, and that's how you dump the dust out. I just ruined the hokey pokey for the rest of your life. You are welcome, and I made that up, and it's great. Yes! I hope you enjoyed this episode of Smarter Every Day. It was brought to you by Audible.com. Audible, as you know, is a really cool way where you can listen to audiobooks on your phone. Yeah, you're smart people. You know where this is going. This is my Audible.com library, and right here at the top of the list, yep, you guessed it, The Martian by Andy Weir. I know there's a movie out, but if you haven't experienced the book, you really need to do that. You can get any audiobook you want for free at audible.com/smarter. I recommend The Martian because there's way more science in the book than there was in the movie that you probably already watched, if you're sitting here watching a 10-minute video about drilling on Mars. Anyway, I'm Destin. Thank you so much for even considering watching 10 minutes worth of a video on the internet. I know that's a long time. Anyway, please consider subscribing if this added value to your life. Please consider supporting the sponsor. If not, no big deal. I appreciate you. I'm Destin. You're getting smarter every day. Have a good one. Bye. Is it out of bounds? I think it's out of bounds. Is it out of bounds to ask if I can high-five the rover?
You cannot do that because of EST.
Can I? Okay, you're grounded, right?
So I'm grounded. We have.
Can I high-five you? Which is kind of like high-fiving the rover because you're at the same electric potential. Can we do this? No?
That's such a weird question.
We hold this? Yeah! Me and Megan, we're like friends now. It took like 20 minutes, but we're best friends. She's about to let me run a command.